So as we've seen in the previous lesson, to be able to differentiate a function, it has to be in a differentiable format. So that means that you're not allowed to have any products or any quotients. So you're not allowed to have any brackets where you would have some products, you'd be multiplying, and you're not allowed to have any x's in your denominator, because that would be classed as a quotient. You would be dividing by your x's at that point. So everything has to be on the one line. You also have to get rid of your surds as well. So you have to know your rules from National 5 indices. So I'm going to start off by looking at example A. So right now, that's not in a differentiable format because we've got our brackets. There are some multiplications going in there. So because there's products, we have to deal with that first. So that function is actually going to be x squared plus 4x minus 5. So that would be a differentiable format, something where we don't have any brackets, we've not got any x's on the bottom. We'd be quite happy to go from there. So by now, you should be feeling pretty comfortable with your differentiation. So I'm just going to differentiate this quickly. That 2 moves down, multiplies by my 1, which gives me 2x. I've got a 4 and an x with a power of 1, which is just going to give me that 4. So for answer E, we get 2x plus 4. Moving on to example B. So in example B, not only have we got surds, we've still also got this product in it. So we're going to have to manipulate through this to get it into a differentiable format. So first thing that I'm going to do is deal with the surds. So remember, the square root of x is actually x to the power of a half. The 2x squared is absolutely fine. And then that root x is x to the power of a half. So now I'm going to have to multiply out my brackets. Remember, if you're multiplying your 2x terms, you would add your powers together. So that's going to give us 2x to the power 5 over 2 minus x. Now, if you're not comfortable with your adding of fractions and putting your powers together at this point, remember you can do working at the side. So to get that 5 over 2, add on a half plus 2. Which is a half plus 4 over 2. Remember, you have to write it with a common denominator, which then gives me my 5 over 2. For my x, I had a power of a half plus a power of a half. Straightforward, that one just gets you to your 2 over 2, which would just be 1. So from there, I can differentiate it. Remember, if you start off with the function y, your derived function is going to be dy by dx. Bring your power down, multiply by your power. So in this case, it's going to give me 5x, decrease my power, gives me 3 over 2. And then x is just going to go to 1. So again, if you're not very comfortable working with your fractions at this point, you can do a little bit of extra working for it. So I had 2 and I had to times it by my power, which was 5 over 2. Remember, 2 is the same as 2 over 1. Now at this point, you can cancel the 2's out. Or if that's not the method you use, 2 times 5 is 10 over 1 times 2 is 2, which just simplifies to 5. So that's how I got my coefficient of 5. And remember, when you decrease that power by 1, so we've got 5 over 2. If we're going to take away 1 from that, that is the same as 5 over 2, take away 2 over 2 for our common denominator, which is where that 3 over 2 is coming from. Now, that would be perfectly acceptable as a final answer, but as I've mentioned a few times now, there are occasions where it makes more sense to have it back into your surd form, and I will point them out when we get to them, so it's a good habit to just practice doing that from here. So I'm going to rewrite that as 5 root x cubed minus 1, and that's my final simplified answer, but as I said, this answer would be accepted as well. Looking at our final example, so this time we've got an x in our denominator. Remember, we can't have that, that wouldn't be differentiable. So for example C, this time we've got the function h of x. Now think back to your algebraic fraction work from National 5. Before you got to this step here, you would have had a step before that written as 2 separate fractions. So this can be written as 2x squared over 2 root x cubed plus 5 over 2 root x cubed. So write that out as 2 separate parts before you start trying to simplify it. When I do start trying to simplify it, obviously I need to get rid of that surd. So I'm going to cancel these 2's out, and this is going to be x squared over x to the power 3 over 2 plus 5 over 2x to the power 3 over 2. From there, opposite from what we've done from B, remember if you're multiplying your terms, you add your powers, but in this case, when we're dividing our terms, we're going to be subtracting our powers from each other. So that's going to give us x to the power of a half. So again, if you're not confident, 2 take away 3 over 2. 2 is the same as 4 over 2, and when you take away 3 over 2, you're left with your half. So that's where I got that half from. This one's a little bit simpler because we don't have an x on the top to deal with, so that 5 over 2 can stay exactly where it is. Our x can move up, and it now has a negative power on it. At this point, we would be able to differentiate. Now, notice that we do still have a fraction, we do still have this 2 here on the bottom, but the rule is that you can't have x's on the bottom. So you are still allowed to have fractions, they just can't have an x in their denominator. And we dealt that by moving that 3 over 2 up to become a negative 3 over 2. So if the original function was h of x, when we differentiate, we get h dashed x. So bring down your power, decrease your power. So when I bring down my power here, it gives me a half x to the power negative a half. Remember, extra working if you need to. Then on this next part, I'm going to bring down my power and times by it. So I've got a negative power, but I've got a positive here. The negative one's in that case, it gives me the negative. So I've got 5 over 2 times by 3 over 2. So top times top, 5 times 3 gives me 15. 2 times 2 gives me 4 on the bottom. And then I'm going to decrease by 1. So remember, you're taking away 1, or in this case, you're taking away 2 over 2, which would give me x to the negative 5 over 2. So that's perfectly acceptable as a final answer, but I am going to tidy it up a little bit just in case there's a next part that's asking me to substitute a number in. So I'm going to have 1 over 2x to the power of a half minus 15 over 4x to the 5 over 2. So that's me dealt with my negative powers. And I'm also going to rewrite it with my thirds. So 1 over 2 root x minus 15 over 4 root x to the power of 5. And that's my final fully simplified answer.